Okay, good. Make sure you turn off, turn off all of your, speakers and all that other stuff. This, turn them on when you need to speak, just because there's some feedback that comes in. Posted an announcement today, first half of class, we're gonna do some data science stuff that I'm kind of interested in. I'm giving a presentation next week. And then we're gonna talk about some GERS posters, and in the second half of class, I'm gonna just introduce everyone to R. I went and paid someone to do some R resources, so I would be remiss if I didn't show you a little bit of R, but you can see, someone started looking at the NASA Open Training. There's been a big push these days on the idea of open data. What do you think open data means?
Available to the public.
Available to the public, exactly. Probably 20, 25 years ago, when I started getting into GIS, and I was mainly into remote sensing with the satellites and all that other good stuff, you had to order like discs from some place in South Dakota, EROS, which is basically the Center for Earth Observation, and they'd send you back this CD, and it'd be really hard. These days, you can go on to things like the National Map, highlight an area, and you can download like NASA data, Landsat data, anything and everything that you want. Way too much data for what you want to do. Tons and tons of data out there for land cover and everything. Because as you know, when we start looking at like drone data, satellite imagery, everything collected using raster formats, that data gets really big really quickly. And most of us know, because when we really want to take an important picture, what do you always need to do on your phone? You got to clear up space, because these pictures take up a lot of space. So imagine doing that for satellites on a regular basis as it circles the Earth. So NASA Open Training, it's not available. We planned on working on it next week. I might change the order of things. I might just say go take the NASA training at the end of the semester when it opens up, because I'm not sure when it is, especially with some of the things going on in the government. And I don't want to push it back and then like, oh, sorry, the NASA Open Training just isn't going to be open during the semester. So you kind of ding on me here. But this week we're going to work on R. It's open source. What do you think the word open source means? Free. It's free. And so it's open to the people who basically utilize it, so you can create libraries and all these other good things. Have you used R before, Daniel? So you know it, right? Okay, a little bit. I know it probably a little bit, and everyone here is going to know it a little bit. And I'm just going to kind of run through a couple of things, because I don't know how many people downloaded or installed it. We're just going to look at some code, look at some of the things we can do. We can do regression and all those other things, multiple regression, because remember, Excel does not do multiple regression. We got to bring that into ArcGIS Pro when we do multiple regression, when we go and map outliers, which is not what we necessarily need to do. And then we got some things about Puerto Rico. I'm going to talk a little bit about Puerto Rico. What is, this is Puerto Rico down here. And I hopped on a plane here. We're going to look at my pictures too. We hop on a plane, and 3 hours later, I'm in Puerto Rico. What is it? Like, is it a country? Is it a state? What is it? What's that? Part of America. But it's not a state, right? It's like a territory. I think it's technically like a commonwealth or something like that, maybe. I don't know. But how do we get it? Because people talk in the news, President Trump wants to, I want to buy Greenland, and everyone laughs at him, but this happens all the time, right? Don't, like, countries don't buy other countries. Yeah. We can laugh at the president for a lot of stuff, but to me, we buy countries all the time. So what do they speak here? What language? Spanish. A lot of Spanish. Some of the people spoke English here. But it used to belong or owned by Spain. So there's been a long history of colonialization since literally the time of Columbus. I think Columbus visited Puerto Rico on his first or second voyage. And so there were, indigenous people who lived there who were soon overtaken via slavery, introduction of diseases, and just outright killed in the search of gold for Puerto Rico. And Puerto Rico is about the size of Connecticut. So it's 100 miles east-west, 35 miles north-south. The big city is San Juan. And in 2007, I worked there. There's a military base down here called Campamento Santiago, which I got to work at, but I stayed in my nice little pool in, San Juan. I just kind of drove down each day and did my mapping. Because back then we would go and collect GIS data using the GPS unit, and some of the GPS units that we utilize in field mapping class. And now I bought a much better map that's a lot better than these, so we can download training areas and firing points and all those other things. Because do you think those are things you should just download off the internet? Army-based data, you shouldn't download off the internet. That would be really bad. So I went and GPSed it, and kept it on our secure servers and all that other good stuff. So the military could train in an environmentally, fiscally, socially responsible manner. And so Spain had this, and I think there was some interest in Great Britain who wanted it at some point in time, because when we look at these, this is part of what we call the Greater Antilles and then the Lesser Antilles. And I think Philip's joining us. Philip, who sits in the front here, and he's from Grenada here, so I don't want to speak too much or put my foot in my mouth here. But you see these Greater Antilles, which is Cuba, Jamaica, this island here, which is Haiti and Dominican Republic. What's the name of this big island called? And if you've kind of ever studied Columbus, this is a big name here. This is called Hispaniola. Hispaniola, and then Puerto Rico, and then you get to these smaller islands. On the as you go around this. Now, how are these islands formed? Just from a physical geography standpoint. Volcanoes. We have a lot of volcanic origin because there's something called the Caribbean Plate. Remember all that plate tectonic stuff back in the day? Here it is. So we have a Caribbean Plate. There's an island here called Montserrat. Zoom into Montserrat, and that's owned by or run by or possession of Great Britain. Where's Montserrat? You zoom into Montserrat and look what color it is. What's all this brown stuff? It's volcano. Yeah, Montserrat. And then you go to another one here called Martinique. This was one of the deadliest volcanoes. This is Mount Pelée, one of the deadliest volcanoes of the 20th century. In 1902, happened right here. So we have kind of all these islands here, because when you think of Puerto Rico, or you think of Jamaica, or you think of some of the Bahamas, especially these really flat islands, but those are different in origin than what you have going on around here. So Puerto Rico so in 1898, we had the Spanish-American War, and we now have, U.S. got Puerto Rico. And Puerto Rico was really important because the U.S. didn't have a lot of possessions back then. Because we have another thing right to the west, right to the east here, called U.S. Virgin Islands. And so U.S. Virgin Islands, right here, we got these in 1970. We actually bought these from another country. You notice these three islands, there's some other smaller islands here. The U.S. Virgin Islands, which are a little bit east of them, because the U.S. wanted presence in the Caribbean, and they weren't really sure what was going to happen with Puerto Rico. Was it going to get independence or whatever? Hey, we need a presence down here because, over here, this is St. Martin, which is kind of run by, it's split between France and the Netherlands. And then we got Great Britain with a large presence here. But we bought it from a country. We're just like, hey, we want this country. Let's buy it from you. And they bought it from country of Denmark. Who owns Greenland? They say, not owns isn't the right word, but who administers Greenland these days? Denmark. Yeah, Denmark. So a lot of times you kind of hear about stuff on the news, which is like repeat of stuff in the past. And I have no political inclinations either way. But what do you think's going on in Ukraine? It's like we want all that land here. We're just here we just gave them a whole bunch of money for it, and Ukraine is a little bit different. And we've seen the results more than 3 years later. And so we flew into San Juan. And then we have a grant with the University of Puerto Rico, Arecibo. So Arecibo is about 50 miles to the west. In the evening, during rush hour, that's about a 2-hour drive. Usually it's about a 1-hour drive. And then Dr. V and Dr. Malholter, they had some students in San Juan. It took them like 3 hours to get there with the accidents. So it was, one day it took them about 3 hours to get there. It was really, really difficult drive, because they have interstate highways and whatnot. And then we also have the project with the ECU. So ECU, us. So I've been down to Puerto Rico twice. I did a lot of stuff. I'll show you some of the things that I did, but some of the things about Puerto Rico is that it's in the path for hurricanes. So in 2017, this is the big one they talk about, they had Hurricane Maria. And in some places, they were out of power for 11 months, out of running water for a couple of weeks. And they come up from kind of this side right here. They come up from the south here, the hurricanes mainly, because they're coming from kind of the tropics in Africa to the southeast. But Hurricane Maria 2017. And so it was kind of really interesting. So it destroyed not destroyed, but really compromised their grid. So these days in Puerto Rico, there's a big push for solar power. So wherever you drive, you see a lot of solar power. And these days, who can afford the solar power just like in the United States? Middle class, upper middle class, and rich. And probably not the rich, because they don't really care. They'll pay whatever, $700 a month bill, $500, I don't care. And especially in the United States, who wants to, is the power companies going to push you to buy solar? Why not? They want their money. We want to be dependent upon Duke Energy. Every once in a while, I kind of get the idea to go and look up, solar power, and people start talking about me loans and 20-year loans. And I'm like, no, I just want the little panels. I plug them in somewhere. I call Duke and say, pay me, pay me. And it never seems to work that way. And I know people out there want to do that. I'd like to do that. There's a whole lot of, solar power, so push for solar power, because they don't want to be dependent upon, the state, United States or whatever. Another thing about it, there's just gigantic wealth disparity. So, driving here down Roxborough Street, you see those beautiful homes next to homes that are literally condemned. So you see this wealth disparity that I think is a little more pronounced in Puerto Rico, where you have like really, really, really rich stuff, surrounded by, people like sitting and like walking through the street, saying, walking at you in your car saying, give me money. And you're like, I gotta get around you, because they're pretty bold. They're just like, you either hit me or, go around me, or because when you stop, I'm going to go to your car and I'm going to hit you up, for some money here. I stayed over here. You can see this. You see, so I stayed over at the beach. I'll show a couple of pictures here, but it's really neat, really interesting. Obviously they use the dollar. A lot of people spoke English. There's some people who spoke absolutely no English. So the first day I drove into security, woman spoke absolutely no English, and I think I knew enough Spanish to get by. But it'd be really good to be, bilingual. So being bilingual here. And so when we talk about the idea of colonialization, first colonized by the Spanish and then the United States, because these days, does Puerto Rico vote for a president? Maybe they have one vote, or they have an advisor or something like that. And so a lot of the policies that impact Puerto Rico, Puerto Ricans really don't have a say in it. Kind of like Washington, D.C. What does it say on Washington, D.C.'s license plate? What does it say? What does it say on? Did you ever live in D.C.?
No, but I have a lot of friends there.
Yeah. What does it say on Washington? It says taxation without representation. Why? Because they don't have anyone in the Senate. They definitely don't have anyone in the Senate, but I don't think they even have anyone in the House. And they might have one or two people for voting for president, but the things that impact the United States, Washington, D.C. really doesn't have any voting power for. And so, I think it's the same way with Puerto Rico. And so kind of very mixed feelings. They have a rainforest. I'll show some pictures of the rainforest. So this is the only tropical rainforest under the auspices of the U.S. National Forest Service. And so, cause I don't want to say United States, but it's pretty neat. You can probably drive around the whole island on a good day, maybe in like 6 hours or something like that, because there's interstates in the north, here are interstates, but you don't get too many interstates kind of going around the rest of the area. But they have Walmarts and all that other good stuff. My wife, she just wanted to stay in the little resort and didn't want to leave, and she wanted everyone to speak English. And I have her, $10 mint, what are they, mint mojitos and all that other stuff. You know what I mean? She was like, because we went to Walmart and it was like, it was lines and people, and it was in the middle of like a rural area. So it wasn't in the city. And then like, where all these people come from? They're speaking all this stuff I don't understand. And she, looks like a Karen, and I think sometimes acts like one. So Karen, Karen, we rule out of place.
She's not gonna see this recording in class, is she?
Um, I hope not. So, Karen is but she's sweet, sweet lady. So. But any questions about kind of some of the geography of Puerto Rico? Because I think we took 3 of our students with us that were part of this project. We're going to be expanding the project. So if students want to kind of be part of this, and we hire postbacks, which are undergraduate students who aren't graduate students, we're kind of hoping that they can transition to master's students, maybe some students who had some kind of lack of skills or maybe need a little bit more training at writing, just preparation, life skills, all those other things that might not have success in the graduate program. We have a couple of postbacks. One of the postbacks got a position, got a master's position, and also hires a master's student. So I know we're looking to expand on that. So I know there's funding. Dr. V runs that. Don't think about it, Daniel. You're working for me. Andy, Chima, no. What's that? Oh, okay. Yeah. Okay. So no. You guys are stuck with me. So okay. So I got some pictures here. I thought these would be neat. They look so excited sitting in the car. But this is this is the tropical rainforest. So literally, you drive up and it wasn't raining there, but it's literally rainforest. So and all these are about 4,000 or 5,000 feet. You drive up. The roads aren't like the United States, so we're you're going around edges and things like there's guardrails and things like that. But beautiful rainforest, what kind of seems like this. Lots of beautiful hiking trails. These guys, we hiked a little bit and went up some things or whatever here. But these were some of the things here. This is on our way out. He was so excited. It was their first plane trip. You can see Isla del Encanto. This is Island of Enchantment because this is the castle of San Felipe El Moro. And so when we zoom into San Juan, this Castillo San Felipe El Moro. This is that way to get into San Juan. So we have all of these castle structures that protect the entrance of San Juan right here. And these castle systems run all the way around. This is old San Juan right here. It's really, really, really pricey, as you can imagine. So this is the bay where, invaders and all those other things wanted to kind of come and, park here. Because it's hard to park along the beaches or whatever, or along the beaches here. And so these forts were really important. So they have these amazing fort systems along there as well. So I thought that was interesting. This was the beach. The north side has a lot of rip currents. I'm not sure why, but this was the beach they stayed at. This is my wife. Yep. And then hanging out there. This is what they did. I got to hang out at the bar with one of them. So my $10 beers and whatever. And this is our student. Baron, who presented. So these are some other students. This guy's Juan and John Carlos. These guys are looking to come up for our field mapping class in May. Yep. And they speak pretty good English. One of them speaks like perfect English, amazing English. Probably better English than some of us here in the United States. And this guy, I think his name is Jose. He goes to ECU, so he went to this school and now he goes to ECU. He goes to ECU. This is Baron, our student who presented on our cemetery mapping project. More of this. What else we got here? Here. Okay, now the other thing, and I'll mention here, is that when Puerto Rico, millions of years ago, the northern part of it was all underwater. And so a lot of limestone was deposited in the northern part. What's limestone made out of? With a bunch of different rocks, but what kind? Shells, composite of living things. Yep, so it's basically, kind of like Florida. Florida was underwater at one point in time, and then sea level went down. And basically, what was left is Florida. Now, what happens in Florida a lot with homes? You see on the news sometimes they literally sink into the ground. Why? Because it's made out of this limestone. Sometimes they use the term karst topography. Has anyone heard that term before? Karst topography, so these kind of like little hills right here, and Florida doesn't have these, but Kentucky also has this as well. And you get enough water into these old shells and marine life that are millions of years old basically dissolve, and it gets weak enough and they collapse. And if you happen to have a house there, then your house just falls into the hole. And so we have this karst topography there. Now, a lot of times we have the karst topography, but one of the results of this are caves. So these caves, basically, you got your stalactites and stalagmites. And so we have an entire cave system, park of caves here in northern Puerto Rico, which are really important for ecotourism. Because the big thing is, how do we make money? Because I went to Walmart and the food costs about the same. Cars cost about the same. Houses cost about the same, but income isn't the same. The gas is they do it by the liter. It was about 75 cents a liter, which is like a little more than $3 a gallon. I'm looking at our liter people here. Does that sound right? And you're doing conversions here. Okay, but it was about 75 cents a liter, and a liter is
Close to a quart.
Yeah, just more than a quart. So it's like 3.78 or something like that. And they do distances like miles per hour. They do in miles per hour, but then distances on the road and exits are all in kilometers. So I see like exit 80, and I'm like, I got 80 miles. No, I don't have 80 miles. I've only got 50 miles to go. Because they're doing it in kilometers. So all the exits are in that. So, but the same speed limit, like la velocidad máxima es, 65, 55, whatever they have there. So it's kind of a different, combination. So they got these caves here. It was really neat with the caves where that they have, this is our student Baron. They have these caves have their entirely separate ecosystems, and I thought it was kind of neat. This is a combination of a spider and a scorpion, but it's harmless, it's harmless. And he let it walk on its face. Every one of our students, yes, he sits in the back there and mapped cemeteries for me, and this is what he did. This is what he did. Wow. So, but we got our caves here, other things. Let's see. Oh, these gigantic frogs live in the caves here. And they have crabs that live in the caves. We're probably 20 miles from the ocean, 20 miles driving, and they got these, crabs, and they also have bats. The bats were really small, but we had a good time with these. And this is Baron. He presented a couple weeks ago because Wednesday, Thursday, Friday, I'm going to be presenting on our cemetery research at the North Carolina, North Carolina GIS conference that happens every other year. I'll talk about that in a second. But some of the things we did talk about, and then our GPR and all that. No one wants to see my wife's pregnancy video, do they? So, but it was pretty neat experience, pretty neat cultural experience. The food was good, but food's just as expensive as, around the touristy areas, it's, expensive as, really expensive as well. but it's pretty good. But I think the major focus of it was really how do we increase um, geoscience literacy and geoscience opportunities for minority students, African American, what are some of the, Hispanic speaking students, since we work with these, and what are some of the barriers? And, sometimes I come from a different lens because I'm just some middle-aged pasty white guy and don't know some of the barriers that our students deal with. So I'm always open to ideas to increase interest in the geosciences for people who traditionally haven't had access to these, because we've got these students, going to Puerto Rico, doing some of these neat things, and most importantly, making contacts and meeting people who can help you get that into that graduate program or that next job or whatever. And to me, that's the most important thing out there, facilitating the contacts. Now, speaking of which, I got a couple things coming up this week. This week, we have the North Carolina GIS Conference. This is like my Super Bowl, and it happens every other year in March. This year, it's in Winston-Salem, North Carolina, but every other year, it's basically GIS for the state of North Carolina. We're bringing Daniel, we're bringing Andy, we're bringing Chima, we're bringing, I think, my postdoc researchers, we're bringing Caitlin, who's an online student. I don't think Caitlin's joining us. She took this class last year.
Tony.
We're bringing Tony, Rizwan. Who else we bringing? Oh, Cameron. Who else? Michael. Okay, we got about seven students. 7 students who are going to present posters and submitted abstracts to present with GIS professionals in the state of North Carolina. And then we got some, newer people here who are just going to go and attend and make some good contacts here. I think, Chima, you're doing a poster there? Okay, and I'm going to show some posters here in a little bit as well. I told you the first half of class, I was going to kind of talk about some of the things we're doing here, but this is a big deal. This is a big deal for us. We got a couple student awards, and they're really, really competitive. It's called the Herb Stout Awards. So we have an online student who won the graduate student award. She did some really good work on interpolation routines. And then we got Cameron, who's our undergraduate recipient, who's doing some mapping on motor vehicle deaths. And he already has a job, and he works for a planning commission locally, and he's doing some really good things. So he's going to take a couple of days off. We're going to go hang out in Winston-Salem for a couple of days and just go and meet with people in kind of the brain trust of North Carolina GIS. Maybe we meet your next PhD advisor, your next boss, your next colleague, your next whatever. And I always take pleasure in seeing our former students there. There's a guy named Corey. He lives locally. He works for Durham. Came down here and he's like, I don't even know what this GIS stuff is. And now he, instead of GIS, I don't know what this GIS stuff is. And now he maps sewers. Map sewers and writes arcade for the city of Durham and bought a house over in Alamance County. Did anyone see the job announcement I just sent out about the parcel mapping for? I got to get on someone about that because I'm pretty sure I sent it out. Oh, Alondra's like, no, I sent it out last week because there's a kid named Zuri. He's not a kid. He's a guy named Zuri. He was one of our former students. He does the parcel mapping. When you go to like Durham County Parcel Mapper and you click on the little polygon and all that information pops up, who do you think did it? This guy did. And he got a promotion and they need someone to go make the little parcels and change the information when it gets updated. And who did he send it to? Me, because maybe one of you can do this work. And this is like full benefits, full time. Probably starts in the mid 50s, 55, and then you work your way up from there. So, but I'll probably see him there. He's always training. He came here as a history major, and he was one of our Geography Bowl people. And he actually competed in like the World Geography Bowl out at the Association of American Geographers. He knows so much random trivia stuff. I thought I was smart with that stuff, and he knows. He's amazing. Is it in there, Alondra? You got that announcement? Okay. Apply for it. Please apply for it. Okay. And then speaking of which, next week I'm going to the Association of American Geographers. This is this is the world's biggest meeting of geographers in the world. Last year was in Honolulu. I definitely went there last year. I had a kid who was living there at the time. This year it's in Detroit. I'll go to Detroit. I don't mind. So, but we have, so our students that were in Puerto Rico are presenting there. And then I'm doing a presentation. I want to kind of show you because it's got a lot of data science elements. So I'm going to show you a presentation I'm doing today. And then I'll talk about the GERS posters. We'll stop and then we'll kind of open up a little bit of some of the R resources and then call it the day because like Wednesday, I'm game on. I'm game on. I'm coat, I'm tie, our students are going to be game on too, and probably go out and have a little, go out and have a little bit of fun. So I'm giving this in a couple weeks. And so as you can tell, I'm pretty busy, these days. And then the following week, Andy and I are going out to Greenville on Wednesday the 2nd. And then the following week, we got a group coming from NASA, and then we get taken about 11 students to the North Carolina Space Grant meeting over in Raleigh. I'm not taking, they're taking them, and I'm just showing up and kind of whatever. But we have a number of students presenting over there and attending. So I look forward to students getting out there and doing some great things. But this is the presentation I'm going to give. This is called Geospatial Sampling Techniques to Optimize Source Locations Applied to the Study of Food Availability. When I got to Central, I had a student come in and her advisor had left and she's like, I'm doing stuff on food deserts. And I'm like, what's a food desert? I don't know what food desert is. And it was during President Obama's administration. What was his wife really big on? Nutrition and health, exactly. Nutrition and health. And so this food desert stuff kind of tied in with it. And so I'm going to talk about it a little bit. The whole idea of food security is having physical and economic access to sufficient nutritious food that meets their dietary needs and food preferences for an active and healthy life. I'm sure we know these days one of the biggest epidemics, pandemics isn't COVID or any of these other things. It is what? Food shortage, and then also us eating bad stuff. What do people die of these days in the United States? Diabetes, heart disease. These are things that take place over a period of time, and they're confounded by genetic predisposition, but just all the garbage that we put into our body. And my wife is really sensitive to those. So we make smoothies and do all these other things, but I'm gonna stop for my little slices of pizza on the way home. You know that. Yeah. What's that? I'm gonna slide a little box under my car seat so no one sees it and kind of sneak it into the garbage, the outside garbage. But all kidding aside, pillars of food security, food availability, food access, and food utilization. And so the idea of food availability is fresh food around? The whole idea of geography is that things that are nearer to you have more of an impact than things that are further away. Now, access is problematic because even though food is available around you, can you get to it? If you don't have a car, how are you going to get food? You got to walk. Public transportation, which takes time. And these days, we got ride shares, which do what? Cost money. And we know how much it is to take an Uber or whatever. Or it's increasingly problematic for older populations. Like my grandmother, at some point in time, my parents said, Granny, no more car. So she was stuck right down the street from, all of her supermarkets, but she had to wait for my aunt to go and pick her up and take her and all these other things. And that's difficult as well. Also food utilization, and that's at the individual level where that if they put a farmer's market right next to you, are you still going to drive 10 minutes to go to fast food? And one of the things I always thought was interesting was that I have a rental car. I have a rental house in northern Greensboro. It's in the middle of nowhere, kind of quote unquote the middle of nowhere, but it's right around the corner from Lowe's Foods. And if you know about Lowe's Foods, they usually serve like better food. Like I like going to the deli because most of it's pretty good, and they got sushi and fresh sandwiches and fresh fruit, a lot better than Food Lion. But when I cleaned out the garbage on that Airbnb, what did I see there? I saw Popeyes and Wendy's and all that other stuff, and I'm like, where's the nearest? I don't even know where it is. You know, it's gotta be 15 minutes away when you've got these options like literally out the front door, and the next thing you see is that Lowe's. And so even though we have these healthier options, and it has a Subway there as well, which I kind of think of as healthy, but technically fast food, are people utilizing the food available to you? Because these days, we know with like corn and fresh food and all these other things, people raise the price on those. You know, so there's a whole cost thing attached to those, and you have to eat it. What's that? Mhm.
Hold on. My name, the food restaurant.
Well,
It's a bigger bag, but
yep, and I'm, you know, we have an air fryer, so we go and make them, but, you know, it takes time to make them, and, it takes time to make them, but yeah, and I'm addicted to the McDonald's fries, I love it. With the whole goal of food, stability. We want food stability. And this talk is really going to focus on the whole idea of how do we measure availability? Because when we started doing this research, we talked about the idea of food deserts as probably originally proposed by First Lady Obama, where that it was just you're far away from unhealthy food. So there was a poverty component, and then there was a distance component. And this distance component was used using a buffer, which is basically a circle. But do we drive in circles? No. We hop on roads and we drive, because when I open up my phone, do I care about how many miles it is or how long it takes me to get there? I care about how long it takes me to get there. And that's a whole nother set of calculations that we look at. And then with food access, do we have transportation to this food? So, and then with utilization, what are our spending patterns? We have access to all of these data, and how do we utilize these? And so I'm largely going to focus on these. Now, when we look at the study of these, we have something called food density, and we might have an enumeration unit here. Enumeration unit, those of you kind of new to GIS, is just a polygon. It could be a zip code, it could be a census tract, it could be a zip, whatever, a county. But it's just an enumeration unit is a polygon where that we can measure this one versus this one versus this one. And density is the concentration of food sources within an enumeration unit. Because I can go and count these. Like there's two good ones represented by green. There's 1, 2, 3, 4, 5, 6 represented by red, but it's problematic because there might be a lot of people who live there or not a lot of people who live there or area or whatever. And so we can create these metrics such as, hey, there are 2 healthy food sources per square mile. There are 6 unhealthy food sources per 10 square miles or per square mile, so that we can normalize these a little bit. Because, in Geostat, we talked about the idea of normalization, meaning if I were to map homicides, what county is going to have the most number of homicides? Chicago, definitely Chicago.
Yeah.
But why? Because they have so many people there. In North Carolina, Mecklenburg County, Wake County, Guilford County. Why? Because they got the cities. But when we normalize by population, we're actually looking at like rural areas, especially southeast North Carolina, where like their gun rates are really high compared to other places. And then we can compare it to other enumeration units. Another way that we can measure, and then we could just make a map across that of all the different densities at the block group or census tract or zip code level. Now, another thing we have is proximity. How close are you? That's all I care about at the end of the day is how close am I? I type in fast food or McDonald's or whatever. How long does it take me to get there? And so we've got some calculations where it says, oh, the distance from the centroid is 1.3 miles. And this is what we call Euclidean distance. Euclidean is just straight line distance. Remember that from last semester. Now, this is problematic because what if the centroid, remember the word centroid, right? And centroid is just a fancy word for what? Middle, center. That's all it is. Now, this is really short just because this green star, the healthy food source, happen to be really close to the middle, right? But it's really easy to calculate. So if we have 700 zip codes in the state of North Carolina, we're only doing 700 calculations. So I can say things like the distance from the centroid of the polygon to the nearest store is 1.3 miles. But it's really easy to compute, but there's gaps. Like if this wasn't here and I was really far away, this distance would be really far. You know, even though people live here and here, but it's really, really easy to calculate because the impetus for this research was that, or the impetus for the study was I kept crashing my computer, like running these, and I didn't want to crash it. Now, the other thing we start to look at is we have multiple houses here. And so another way that we can measure is that I've got a house, I can measure the straight line distance, which is really easy to calculate. How do you measure distance how'd you measure distance in math class? Didn't we have something called the distance formula? Delta x squared, square root of delta x squared plus delta y squared, right? We do the same thing here, because remember, when we flatten this thing out, we turn it into planimetric measurements, right? Just x's and y's, but they're not like 2 comma 6, they're like 400,023.7 comma 2 million, just on a flat surface. So we can do this, or we can do like nice little drive time on the roads. So we can say, 1.7 miles, 5.2 minutes. I can go to say another house and do the exact same calculation. And then I can do it for every single house in this enumeration unit. Do it for every, now this is pretty cool, huh? Every single house in this one, every single house in this one, every single house in this one. Now, when you run drive time calculations, we do this all the time. You run drive time calculations. Siri, I want to go to my pizza place on the way home. How many calculations do you think it's doing? Wow, whole lot. Basically, it tries to get me to Route 147, because I live in Greensboro, get me to 147 as quickly as possible. It knows to take 40, and then I got to kind of go down the street to my little pizza place. So we're doing hundreds, if not thousands of calculations. So a lot of times if you have like bad reception, it might take a few seconds to run these calculations. So whenever I run the calculation from this house to the nearest store, because is this the nearest or is this the nearest? Got to figure that out first and then do the calculation. So when we do this, we're doing probably 20, 30, 40, 100,000 calculations for this house. Same for each of these other houses. How many houses it might be in a county? A lot. A whole lot. And so some of the things we can look at is, hey, the average drive time to healthy food equals 11.1 minutes. Now that's a lot better than the centroid, it's a lot better than density, it's a lot better than raw count values. In addition, we can say average drive time to unhealthy food equals 8.4 minutes. Because in addition to being food deserts, we have things called food swamps. The food swamps are these areas with lots and lots of unhealthy food options. Look at around NCCU campus. There's just fast food and there's some restaurants down Fayetteville Street. Right? That's it. Where do students get healthy food on campus? You can probably take the bus down to, down to Food Line, right? Maybe. Okay. And you notice around college campus, a lot of food swamps. And then we also look at things like food ratios and things like that, because we can look at variety. Hey, what is the relationship of healthy to unhealthy? Hey, you've got 6 unhealthy, you've got 2 healthy, you've got 3 times more unhealthy than healthy, where that some other county, there might only be the same amount of unhealthy versus healthy. So these are all the things that you can. Now the problem is that when we geocode and run all these calculations, it takes a really long time. And then finally, so and the sizes and shapes of enumeration units can lead to MOP, which is called the modifiable area unit. And then we also want to make sure we get like buffer areas, because hey, this one's closest, so I got to make sure I keep areas outside of my study area, because I might want to go to one outside of the study area because this enumeration unit isn't an island. So I can make these calculations. And so the research question that we had was, when I calculate, this is up where I live, this is North Greensboro, that red star is that Lowe's that I was talking about, and like 2 houses to the left of that star, 2 houses to the left of the red one is my little Airbnb, or my wife's and I little Airbnb, and now it's rented out. Now we rent it out because Airbnbs they're a lot. You see some really bad stuff. It's not pretty. But that's another issue for another time. But you can see where it is now. That last one, I would have to calculate the drive times from every single residential location to the nearest store. And there might be a store down here. This is pretty rural, not rural area, but pretty isolated area. Think about how many different calculations. How many calculations am I going from this to that? Lots of them, because I gotta get on the road. Hey, I'm gonna go down this street. I'm gonna go to the next one. I'm gonna go up here to the left. If I'm over here, what roads am I gonna go around here? What roads am I, just think about the dozens and tens of thousands of calculations and multiply that times 177,000 for all the total calculations in North Carolina, in Guilford County where I live. So when I started running these calculations, I said, hey, run the drive time from every single residential location to the nearest supermarket. You know what my computer said? Well, I'm done, I've crashed, sorry, you know? And so I did have a grad student, because that's why we have grad students. I had a grad student go and do it for me, and he broke them down into like, hey, break this down into like 20 separate groups and, you know, run this back to me. So is there a better way to sample this but not compromise results? Because at the end of the day, I want results that match up with every single calculation. That's what I want. And I had a grad student go and run it, you know, and it took him like 5 days. His name was Richie, His name was Richie, and he ran and did every single calculation. So for this store, you know, it's 7.2 minutes. For this one, it's 6.95. For this one, it's 6.86 minutes for every single location here. It's pretty cool. So can we take samples? Can I just say, hey, let me get, now what's this shape called from you geostats people? What does this look like to you? Grid, yeah. What do we use? What do we call it in geostats? Remember what it's called? Fishnet. You know, this is a fishnet, but it's grid because we took the little middle things right there. Exactly. Or we sometimes use the term lattice. That's another one we use. So if I just said, hey, let me get a sample grid and run these calculations and then group these by zip code or census block group, am I going to get the same results if I run everything? And so what we did is I ran it for Guilford County because that's over, you know, that's where I live. And I wanted to do that. And so I extracted the centroids for all residential locations from the North Carolina parcel mapper just for residential locations. I calculated the drive times for 177,000 source locations to the nearest supermarket. So here's the supermarket. And so you can see what I did was I created a subset of these locations as possible source locations. And I ran every single, not me, my grad student ran every single one. And you can see the map here. So you can see 3.8 minutes. And this is my house right here. This is a little farm thing here. It's between 0.8 and 1.3 minutes to get to this, you know, get here. And there's also a restaurant and a subway.
So you have.
Yeah. Yeah. What's that? Yeah, it was, yeah. And that, yeah, this is our place right here. But I usually live like 5 miles that way and I rent out this place. My wife wants to build a house here and I'm probably gonna have to because that's what she wants. But she likes farming. We had chickens and stuff like that and she's got tiller and all that. So we go out there to do that stuff. But yeah. And so I had a grad student make a map like this for every single, you know, and it took them like a week here. But some of the sampling techniques we looked at were the block group centroid. Okay, let me just take the block group centroid. There's 292 of them. The population weighted block group centroid. Geostats people, what's population weighted mean? Yeah, normalizing weighting by property. So if I balanced it and every person weighed the same, if everyone weighed more here, I'd have to move the center over here. It's basically a center of weight or center of mass, assuming every person weighed the same. And this was based on block level data. So I need a smaller enumeration unit to know where the people lived in the block group. I also looked at block centroids because blocks are the smallest unit that we have, but there's only about 2,745 populated blocks. Literally blocks are blocks where we count people, with all this 2020 census, and soon will be a 2030 census. With all this census stuff, we basically know, we want to know where people live. Hopefully that's all we want to know. I think these days, I think we want to know where people live. They don't want living here. We have a half-mile fishnet, a quarter-mile fishnet, random points, and then I did some stratified, where I said, hey, in this block group, if it's got more people, we put more points in there. And so you can see the number of sampling points here, because originally I worked with 177,000 and say, hey, I'd rather only run like 290 calculations or 10,000 calculations or 5,000 calculations than all 177,000. So these are what these look like. So this is like every single residential location up in Northern Guilford County where I live. This is just randomly placed points here throughout the county. There's 5,000 of these in all. And say, let me just put random points here. Here's a quarter-mile fishnet. And then this is like stratified random, which basically means we're going to put more points in areas where there's more people or area. And so these are the maps that we got here. These are the maps we got. So you can see these dark areas have the highest drive time to supermarkets. The light areas have lowest drive time. And this is at the block group level. There's about 292 of these block groups. Block groups are just subdivisions of tracts. Tracts are subdivisions of counties. And so when we start counting people, because these days when we say how many people live in the county, there's a lot of diversity in the county. There's high income areas, low income areas, high minority areas, low minorities, high access to transportation, low access to transportation. And so when we look at things at the county level, it's really kind of meaningless when we do high scale research like food availability. All right, here's another one. This is the drive time using the block centroid. So this is using the block. This is a lot more kind of nuanced, right? We can see up in the upper left, that's a by right or something like that. That's way up in the upper left. Okay, we've got some down here. If you guys know Dr. McGinn lives down here. Okay, I live up in the northern part right there. Okay, here's another one, same exact map here, but along a half-mile fishnet. Okay, you notice some gray areas because we happen to have areas where there was no fishnet in there, so we don't have sample points for those. Now, those of you who know me from geostats, what's my favorite statistical test in the world? Exactly, two-tailed t-test, yes. And basically what we're going to do is, hey, let's compare the results we got with all calculations versus this, using a nice little two-tailed t-test. And all it is we're going to measure one distribution, right? Sample distribution, bell curve versus another bell curve. And they're the same thing, just you measured differently, right? So remember, we had the null hypothesis, we had the alternate hypothesis. And when we run it, these are the results we get. Mainly what we have is that there's only one technique where they are statistically different. All the rest are statistically the same. And I'm kind of like, okay, right? Because remember, what do we care about in statistical difference? Anything less than what? 0.1, 0.05, 0.01. They are statistically different with 99% confidence, 95% confidence, 90% confidence. They are different with 34%, 67%. They're statistically different. Or in this case, they're not statistically different. What are we really saying? We can't prove they're different. And so there's some semantics that we talked about in the past where that, all right, that's cool, but we have equivalence testing where that if we have insufficient evidence to reject the null hypothesis, it might not imply similarity in the type of, and the probability of making a type 2 error exists. So if we don't reject the null hypothesis, it doesn't necessarily assume equality, right? Just because we didn't reject it doesn't mean they're equal. And so just in like since 1996, I've been kind of going through some of these statistics, and we've got a couple of ways to kind of prove or try to prove or disprove that two things are equal to each other. So we have paired equivalence testing, two one-sided tests for equivalence. And I thought it was appropriate because these are things that I did in R that we'll do after the break here for a little bit. And so everyone kind of remembers this now, right? And remembers this, where that when I ran, and we'll look at this stuff in gray, and we'll look at the results in gray, for all Guilford County residents, for all 177,000 residents, the average time to drive to the nearest supermarket is 3.998 minutes. Okay, the average drive distance was 1.701 miles, so 3.998. So things that are close to 3.998 are probably going to match up with the regular calculation. So this 3.917, yeah, that's pretty cool. And you notice it's like 0.665, so they're, you know, kind of higher. 3.893. Remember when it's not only average, but the distribution of these, distribution of these, which also looks at what? Variance and standard deviation. So we're comparing everything to that 3.998 as well as all of the data that goes into it. So we did this equivalence testing right here. And so I ran tests for dissimilarity, which I thought was kind of interesting. So the 3.998, I ran it all again. And so when I look for dissimilarity, the dissimilarity was rejected, which implies what? Similarity. I don't know why they just said test for similarity. We were rejecting tests of dissimilarity, which is a fancy way or convoluted way of just saying they're similar. But I just ran it through R. I wasn't going to invent anything new, write my own new code, and I found this stuff in R. And so we can see when we use the population weighted block group centroid, when we said, hey, the center of the population is where all the center of the people are, and did that calculation from that point to the nearest, because here we're only doing like 290 calculations instead of 177,000, which my computer didn't want to do. And then the other one we saw, and meaning this, all of these were rejected, meaning all of these rejected. There were two different tests that we made. And then when we ran some random points, 4 per block group, this is stratified, but you can see when we use the population weighted block groups, like it's just as good as using every single location. Now, why do we care? I don't know. Someone gave me a bunch of money. I ran this as part of the paper. I got my tenure and promotion and all that other good stuff, right? But this was a really good practice in like breaking down projects, because a lot of times, you know, I give you these little projects for a week and they're like, you get them done and on to the next thing. But we got, you know, Juan who works, Juan who's joining us online who works, and like I got a deadline coming up, and it might be like a 3-month project, and it's hard, in a class like this to wrap your head around like 3-month long projects where a lot of data preparation, a lot of data analysis, a lot of data interpretation. So I think this was really good in, how do we get the stratified? How do we create fishnets? How do we run the network analysis for all these? So my conclusions are, this has been a real long talk, is that when we use the population weighted centroid, block group centroid, and a stratified random technique at the block group scale, align best with the results for our residential parcels. Because at the end of the day, I didn't want to run availability calculations for every single parcel because there's 177,000 of those, and my computer said no. Because for each of those 177,000 of them, it had to figure out, am I going left or am I going right? Am I taking a right at this intersection or am I taking a left? Just like your phone does. Now, imagine you're asking your phone to say, go to nearest supermarket, and you doing that 177,000 times. But, it's hard enough like one time, and then another and another, and you know, your phone is going to crash, and your typical desktop computing solutions are going to crash as well. Three techniques, but the thing that I like was population weighted block groups. There's only 291 of them. And it worked just as well as everything else compared to centroids, which is about 8,000 versus 1,000. If I put some random points out there, but this is the paper we had. It's in something called Applied Geography. These are a couple of my colleagues over at North Carolina A&T. This is our student Richie, who went and ran everything. Does anyone know Richie? Were you around with Richie Chima? Andy now? But Richie, he was non-traditional student, kind of graduated from Chapel Hill High back in 2003 or something like that. Kind of just was floating around, said I want to go to school, and started Durham Tech, and he's doing Python coding out in Vancouver, British Columbia. So he met someone who was from that area, and he's out there. But really neat paper. These are some other papers that we have as part of this. Dr. McGinn and I, this is Richard Byron. We did some raster-based metrics. Here's a paper that was just published last year. Did we recognize any of the people on this one? Got Chima back there. We got Tony. We got Samuel. Samuel kind of pushed this one. Dr. McGinn and myself, but this one was just last year. Where we did density calculation. So, hey, can I just run raster? Who's taking raster class right now? Did you guys do raster density at all? Well, you can do it, and it makes raster maps, kind of like heat maps, let you see like on the weather, but instead of temperature, it's how many pixels or what's the density of your supermarkets or whatever. And so you can see we got this one here. Do I have another one here? Oh, whose name is on this one too? She's already got 2 papers done. Look at that. This one's a little bit different where we used, how do we define role? Because we get into some of these abstract questions like, what is availability? What's the best availability? I just did one availability metric. There's tons of others. So there's lots of rabbit holes you can go down. And then likewise with this, like what is the definition of rural? We get into some real like deep, and someone says it's the boonies. Well, how do I put boonies in a GIS? Because I want a number. I'm not qualitative. I'm quantitative. How do I put boonies into a number? And there's about 9 different ways that it can be measured. One's using commuting patterns. One's using population density. One's grouped at the county level. There's lots of other definitions, not a lot, but there's enough other definitions where that one definition, here's a rural map of North Carolina, here's a rural map of North Carolina. They don't look the same using the USDA, and they're called RUCAs, rural urban commuting areas. Based on commuting versus census uses population density. It needs 1,000 people per square mile, connect to another 1,000 people per square mile, and so those things look entirely different, especially at the zip code level. So that's about it here. This is our information here. So let's take a 10-minute break. I'll probably just kind of run through some R and run through a little bit of R because I want to show you just some of the capabilities of R. I put together a pretty neat program where we did some scatter plots and other things. And to me personally, if you do stuff in R and you put it in a paper or do it in a presentation, people like me are going to be a little bit more impressed than if you do it in Excel. I don't know what you guys think. What do you think, Chima? Because I can look at a graph and like, that's Excel. And I know if someone does it in R, I'm like, it's probably the same thing, but I'm just a little more impressed because they're using R. So that's me. So let's take about a 10-minute break. We'll come back and hopefully we'll be done by about 6:40. You guys all set for tomorrow?
Yeah, I mean, when you're buying something, so people like very much. In the,
In my own business. I'll be your old lady. Just something. Is Tony doing a poster too?
I think so, he's upstairs, I want to.
No.
Okay, so he's right. Sensitive. But so on, it's due to be what I on the kind of, you know, yes, it's a way. I'm not Spanish. It's due to be. Word. So actually, so more stuff. So more still more like just research. I think we have the next system. From the course of important event that's said we can That's yeah. Yeah. So what about you? Should yeah. So are you? Yes. But and then go in that year. The whole version of that's so okay. Sure, sure, bridge. There's, I think we have like those. Let's say, high expectations. I mean, it's dark. So much besides school. Hopefully this year I get to travel and see that, you know, it was like, oh, when I came, it was just possible focused on like just trying to set something. Get going to school, but hopefully. So some things. Some of it is. Yeah, yeah, I'm right there. I'd like to. Some, I think that know about the. Let's see what we'll get. I get things, so. Yeah. Maybe I'll see what we'll pay for to go there. This guy's gonna go, so. That's one. What is it? Yeah, it was a great experience. It's in the shooting. Yeah. The Samuel out there. Yeah. Seems like. Yeah, it's good. I don't know. You did? Yeah. So after the conference, I was supposed to fly. So immediately got there, and I think that was good. Yeah, like a lot of flights were getting cancelled. So because my flight got cancelled, I had to stay back a couple of days. So I just used the opportunity to have some exams to, yeah, exams to decide. That's great. How would I see that your Bulls gear on? That's cool. Yeah, that is the last time I mean. Okay. But yeah, I mean, did you go into Chicago or no? Stay in Chicago. I think it's well. I had a lot of guns. It's very good fun. And I was like tired from all the work side is yeah, good. And it was like all the things I left here, like just stay with me. So now that I'm back, yeah, same. I wish I had to stay back. Behind me in this class, I didn't do any of the work today. I completely go. Super relaxed. Just I did like a 4 spring break. I got everything done for all of it since like before I got shit was but not this one. I was like, oh, I didn't even get that done when I got back. Saturday. I'm so excited. I don't have do a Python tutorial. Rather than a lot of attention, is if you miss something, you just be in front of the screen trying to figure out why you messed up. Yeah, yeah. You have me very confused. Yeah, I'm probably just alternatively, okay, be fine. Another guy trying to do it right. So that makes sense. Yeah, I couldn't do it being jet lagged. Yeah, it's the second semester. When you finish, someone you want to say work goes down. I'd love to secure a job first. Yeah. Yeah, I feel like I'm decided to bring back home. Yeah, it's still fresh. I think I'm still choppy, so it's yeah. I'd say maybe Belgium. She's got a job. I mean, I'm looking at me. That's the goal, and that's exactly. Also, we're gonna have one other. So that's the money when it's on that. I was just as NCC. Kind of. It's my rating. I think the other day, you said, that's very much used for grounding there. Let's see, hopefully, and also that people she might do it. And then. Yeah, it's not only students. That's it. Oh, you're gonna have this week. So how about you guys can share this? Just. So. Yeah. So I feel less weird. So next May, students getting a class of paper.
Yes.
It's hard.
Where's it?
Yeah. Did you give us access to that
It should be
in the file from today?
if not, I'll post, no, go to modules. And then our resources down at the bottom. So
I'll
you
find
gotta
it.
download.
Okay.
Okay. We're gonna start here. We're gonna talk a little bit of R and then we will be done, probably in about half an hour. I just wanna show some of the bells and whistles on R. I thought about it while I walked outside and it was magically daylight because it's usually dark by now. So Puerto Rico is over here. We're all the way over there. What time zone is Puerto Rico in?
They're like 1 hour ahead of us, right? But I don't.
Sometimes?
Oh, well, depending on the, yeah.
Because they are Eastern Standard, or Atlantic Standard Time, but they don't recognize daylight savings.
Okay.
So we flew out on Saturday and I got there and it was an hour ahead. And then all of a sudden, it was still, when I got back, I didn't have to, all my clocks were. So starting that Sunday, it was the same as the United States.
Okay.
So starting Sunday, it was the same as the United States. The day I got there, they were 1 hour ahead, and then they were the same as the US, because the US skipped ahead or sprung ahead an hour. Now, it being so far to the east, what does that do with like sunrise and sunset?
You get some, you get some.
Yeah, they get sun first. They get sun earlier. So sunrise is really early, like 6:20, but sunset is like 6:20. You know what I mean? So the sun's setting right now. And I didn't like it because my kids, they wake up with like the sun. So I got some like, I got a kid ready to go at like 6:30. Like I'm ready to go to the pool. I'm ready to go to the beach. You know, but they're going to bed at, they're going to bed at 7 o'clock at night, which is good for me. You know, and so that's kind of an interesting dynamic. You know, I noticed that I went out to Louisville a long time ago and they're Eastern time zone, but their sun set, good 30, 40 minutes later than what we were used to. They were just on the other side of the time zone because in theory, or back in the day, what is noon? What is really noon? When the sun is highest in the sky. So even here versus Greensboro versus Charlotte, the sun is highest in the sky at slightly different times. So we needed a way to kind of normalize things here. I'll mention one more thing about time zones because I think it's pretty neat. My wife is here it is, yeah. My wife's from northern Indiana. And so like this little chunk right there, why is this little chunk like in like what? So we got Central Time, Eastern Time Zone Central. Why is this like little chunk of Indiana in Central?
Because a lot of the people who live there work in Chicago.
Yeah, so they want to be on Chicago time.
Yeah.
Because sometimes my father-in-law, because they would go from kind of this area here, Elkhart, and then the other time they lived in, they'd go back and forth. But like you left for work at 7 in the morning and you got to work, took an hour and you got to work at 7 in the morning, Now, what's the bad time out of it? You left work at 5 at night and you got home at 7 at night, So they try to move all these around. These are like really rural areas, but they try to move these around so they disrupt as few people as possible there. But a majority of people work in Chicagoland area. So, okay, I put it all off until now, and now I got to start talking about stuff that I don't know much about. Okay, last couple things here. I got some GERS posters here. GERS is, I'm going to be gone next week, so I'm kind of like, I'm going to be gone. So hope everyone gets it figured out. The library's been printing out posters. We have poster printout capabilities, but I'm only going to be here Monday, and then Tuesday, Wednesday, Thursday next week, I'm going to be at rest of the week, I'm going to be at a conference. The rest of the week, I'm going to be gone. So the GERS, hopefully everyone's following the directions and all that other good stuff, because I'm not going to be here. I'm going to be out with that. But I posted templates in my Google Drive there. Have I posted templates on modules in Blackboard or Canvas yet? I don't know. Does everyone have access to things that look like this? Okay.
You posted something, but it was blocked for me.
It was blocked?
Yeah, I didn't have access.
Okay. If you can, if I think of it tomorrow, I'll post a link to my Google Drive, which shouldn't be blocked, which will have these templates as well. But these templates kind of look and feel the same. This is a student, this is Richie. He was the one who did my Python code and did some other things here, but he mapped kind of Central Durham area. You can see what it looks like. Abstract, background, hypothesis, methods, results. We're doing GIS-y stuff. So how do we really tell our stories? We tell them with maps. We've got a couple of little tables right here that kind of reinforce our points. We tell our stories with maps. And so it's really important that we make high quality maps. Now, those of you coming here the first time, you're like, oh, I don't know how to do this GIS stuff. We got Andy here, and other folks here, or just do it in Geostats next semester and worry about it later. But really powerful. The other thing you notice here is make sure the fonts are the same here. If you indent here, you indent here, you indent here, you indent there, you indent there, the same amount. Consistency is always really important. The one thing I don't like about this is the title, because I can't really read the title because I'm big into contrast. What's this word contrast mean? Difference between high and low. Okay, me personally, I like white, black on white. Why? Because you don't use up as much ink. Instead of black on white or white on black. You don't use as much ink, but that kind of black on the dark, maroon there, that gets a little hard to see here. So I didn't like that. And then also in the bottom, always put an acknowledgement. So if you're presenting a poster, ask your advisor, say, hey, it should be my acknowledgement so I can give it to people who give me money. Here's another one here. This was Adam Lippy. He was the kicker of the football team, and then he left and moved out to Western Carolina and never played football again. But he was the kicker. The kicker here. He did some really neat things where he went inside of some of local food stores and looked. So he did some good work here. The data analysis, just bullet points, conclusions. The one thing, and I've been a poster judge in the past, and I'm not going to do it this year just because I'm going to be at AWG. People, you're going to have a chemistry person come look, a biology person, a physics person come and look at these. They're not going to know all, the blood and sweat and all those other things that went into it, but they're gonna like the way that it looks. Like the way that it looks. Is it simple? Is it easy to read? Can I understand the maps? And so those maps that you should make or the graphics that you should have should be understood from like age 80 to age 88. Okay, those are important. This was a good one here. This is doctoral student Chantel, who took this class last year. She mapped gun violence. We had an Excel spreadsheet of gun violence and we mapped these were the frequency and these were the rates, because as you can imagine, what state would probably have the most gun violence? Illinois and Chicago here, but when we normalize it per 100,000 people or 1,000,000 people, you can see these results. You can see they're spatially distributed. The upper Midwest, where people like carry around guns in their trucks and things like that, really not that high. Queensland, not that high. Southeast, upper Midwest, south here, high. Okay, like I said, in this class, any class, geography class, there are spatial patterns to everything, whether it's ADHD, ulcerative colitis, food accessibility, gun violence. You always kind of think of, gun violence, someone going up and shooting someone as being a stochastic or random phenomenon, but it's really not. It's geographically related. Here's another one, GERS. This is a student who went around locally. This is Benjamin. Do you remember Benjamin? Oh, yeah. This is Benjamin. He went around to local stores and got the prices of local food staples, like gallon of milk, pound of bananas, carton of eggs, dozen eggs. And so he went and graphed those. And so you can see the egg prices now. You know how much eggs were in Puerto Rico? $10 a dozen. How much are they here? Are they that much? Yeah, I stopped eating eggs, the eggs are usually pretty cheap. Now I want to get my chicken, we have chickens at our farm, at our farmhouse and no more. There, we gave them away. Yeah, we gave them all.
The cost of living is similar to.
I don't know, I think they live with more people. I don't think they move as much. I don't know. That's a really good question, because I asked the folks, the professors, how much, what's good pay? And they're like, 60,000 a year. And I'm like, all right, 60,000, you can get by pretty, you can rent a good place here or whatever, but to really get ahead, it's hard. Yeah. I don't know. It's hard. And then here's the last one. I like this one here, just the title I don't like as much, but here we can see some raster maps. These are likelihood of increased wildfire occurrence and drought severity. I like the graphs. I like the charts. I like the consistency with everything here. I'm really, the one little thing here, this little red thing was kind of moved over a little bit, but, judge might notice that. Okay, so just kind of having attention to detail, group all these things together, do it, make it look good, make it look right. To me, the visuals are important. The science behind it is important too. But I think there's been a field of research, and part of my Lit Geo conference that I went to was on scientific communication. Especially in this day and age, how do we effectively communicate science, real life science, that everyone can understand it and it's not biased in one direction or the other. And these days, I think we've politicized things like climate change, and I think we do a little bit, because if we look at this certain area of climate change, we're going to be looking at climate data in a little bit, and we're going to see climate data, and you'll see some of the results. But if you were to look at the results for other parts or whatever, we need to be able to effectively communicate science. And that's why we go to, conferences and all these other things, because I'll give you your A and you have a nice smile on your face and I'll say, great job. But, you're going to be out there with people who I'm going to hire this person. I love the maps they make. I love the way they present themselves. And there's a whole thing that doesn't involve pointing and clicking that I think we all need to be trained up on, that I unfortunately I can't teach. It's hard to teach. I'll take you to a conference, go to GERS, do this or whatever, but you figure out the rest. And it's tough. Okay, so these are some posters here that I have. If I think of them, I'll log it on. I'll log these on. But so what I got here is just R. Okay, now this is R. R is an open source statistical programming suite. That's all it is. It can also be a language as well. And so when you open up R, and when my dad got me into R probably 18 years ago or something like that, because it was open source. It used to be called something called S. And then it's open source, meaning you can download it and do all these other things, and you can add some real kind of really neat packages or whatever. So those tests of similarity, those two-tail tests of similarity that were opposite of the two-tail t-test, that's what I did in R. So I've done some pretty cool things in R. I used to do some cool things in Python, but you all see that, we got Daniel, we got Jim, we got a number of people here that can do much neater and better things than me in Python. I'm just the one who gives out the grades, so another issue in itself. So we can write programs. In the bottom left, we can also like type in commands. So in the bottom left, we have something called the console, which is basically like the command line or the line in ArcGIS Pro when you click on Python and say x equals 2, y equals 3. Now in R, we've got files up here. So I've got data, I got some of my data. This is an R program that I opened up. It's sitting in the resources, so you can run this later. And also I paid someone to do a couple of like R demos. So I've posted those up there. In the environment, we have the environment up here. And in the bottom right, what do I got here? I got nice little plots right here. And whenever I see like plots that look like this, I'm always like, all right, there are people, you know what I mean? And I always like, I can right mouse click, I can copy image, and then guess what I can do? I can pop this thing right into, I swear. I thought I was doing it. Copy image, or I could save the image and then pop it into Excel or anything like that. And I can make these look a little different here, but I can do something like x equals 6 now, or 7. You notice it's got the less than sign and then the little dash. That means takes on the value sign. That means equals to. Because remember in Python we got an equals to sign, and then what do we have also? An equal to sign.
Yeah.
Remember that?
Yeah.
So one was an assignment, one was a comparison, and now in R we've got this little arrow thingy. That's about the best I can describe it. This arrow thingy to assign values. And so I typed in x equals 7. Oops, sorry. X equals 7, enter. And then up in my environments, I should have a variable called, I'm going to say Q is equal to, now Q is going to take on the value of -2. And then A is going to take on the value of 5. And so you can see in these variables here, I've got an A, I got a Q, and I should have an X. And so you can see all the different variables. You can see I wanted to make sure I didn't screw this up like I did last year. So you can see I've got a whole bunch of variables that I've been running here. I've been running here from some of these programs here. And then, so just in the little command line, so I can do something like A times B and it'll print it out, right? So, or A times Q, and it's going to print out -13.5, which is -3 times 4.5, hopefully, right? Yeah, sure. Okay, or X plus Q equal to 4. 7 plus -3 is equal to, I can just type in the word Q here and it's -3. And so remember we did that in Python where we were just running calculations and all that other good stuff. We can raise these things to different powers. And I think we use the caret symbol here, so I can do something like x caret 2 equals 49, which is 7 times 7, 7 to the second power, which is 7 times 7. So in R, I can do these. Now, the other thing that I can do is I can put these into a big, gigantic R program and just run that at the same time, just like we did with Python, right? Right mouse click, edit. You open up a nice little R program, and then guess what? A Python program and run all the things at once, and it's connected to what? Our input parameters eventually in ArcGIS Pro, which was a feature class, a little text box that we converted to a number or whatever. And so what I did here was I wrote a little program here in R I'm gonna kind of go and cut and paste some of these things in here, but the first thing I have is I read in an array. The very first thing up at the top here is I read in an array right here that I've highlighted where I read data. What does read data mean? And this command says read CSV or read.csv. What does CSV stand for? Comma separated values. You guys, so I've got a couple of Excels here. These are the comma separated values. So what I want to do, the first thing I want to do is I want to read it into an array of all of my zip codes. So this is a list of zip code data that has what? I have a column called ID, total pop CY. What do you think that represents? What field is that?
Total population of a city.
It's the current year. Yeah, current year. Yep, current year. That's right, though. I got median household income, COVID rates. Okay, what was the COVID rate for 07, 06, 2020? Poverty rates, percent minority, number of supermarkets. Is it a USDA food desert? Yes or no? Percentage of people with zero vehicles. Is it metropolitan, micropolitan, or rural? Has anyone heard the term micropolitan before? It's between rural and metropolitan. And those are typically going to be counties. And we're talking about counties here that aren't connected to metropolitan areas. So we have things like Orange, Wake, Durham County, which are part of a metropolitan area, where something like Pitt County, where there's Greenbelt, is its own metropolitan area. Yes, exactly. Triangle area. Greensboro. Can you all hear me? Okay, looks like you can hear me. All right,
Yes, sir.
okay. I just, it looks like something went out real quick. I have something called, one of the neat things that I did was for each of these zip codes, I calculated the percentage of Democrats, registered Republicans, and registered unaffiliateds. And then I ran a little calculation to see which one was a majority. Was it Republican, Democrat, or unaffiliated? That's pretty cool. And that's big data that we'll look at in a couple of weeks, where that we have a list, a big text file of every single person in the state and what they're registered as. You can look up anyone. You can look up me. You can see I am a card carrying unaffiliated. Yes. So I am as unaffiliated as they are. Okay. So you can go and look those up. Now, do you think Excel likes working with 7 million voter records? No. And so we bring in the things like R. Now, could I do that right now? It'd probably take me an hour to go and figure out and remember how to do it, because I always have to go back and relearn these things. And I created this. We got median age and we got some other COVID rates here. And so I brought this thing into an array. An array is basically a two-dimensional data structure. Just two-dimensional data structure that has rows and columns, and at the top we've got the little field names like we have in ArcGIS Pro. And then the next thing we do is print everything there. So if I were to Control C, and I'm sure I can run these line by line, but I can run the little command here, and then I can print the entire thing. Now it doesn't like printing everything out. And then I can also print out, it says zip code $ pop dense CY. David just said, what does that CY thing stand for? Current year. So now, instead of printing out all the data, I'm just going to print out everything from that column there that starts at 59, 288, 874. I'm just going to print out every single thing here. 59, 288. I'm just telling it to do that. Why? Because I just want to show you some of the different commands. I wouldn't do this in real life, but you know how I work when I program is I'm a big print person. Print, 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 print. If you print out the right stuff, it should be there. Now, other thing here, I've got print the mean of the zip code of pop density. What do you think the mean is? Yeah, the average. Well, let's print out this thing. So the average of all these columns here. 534. Print the median. Now I'm going to cut and paste a couple of these lines. Oh. So the mean, the median, what do you think SD stands for? Standard deviation. And then I have something here called summary. I assume we have quartiles, medians, means, third quartile, and the max. Now another thing here, I have plot, zip code, let's see what we got here. And I think you all can see what I already got here. But I have a command here that says plot the zip code, plot the poverty rate versus the income. So I'm going to have a relationship between, what color do you think I'm going to make it? Green? What do you think X lab means? Y lab, these are the labels. So these are different. What's that word that we call that are separated by commas in the little parentheses? These are called parameters. And so if I left it blank, what color do you think the graph would be? Probably just black. I assume it would be black. I'm going to run it, and look what I have here in my plot. Okay. So what does this say here? As the poverty rate increases, what happens to income? Decreases. Does that make sense? Yeah. Yes. Poverty rate and income have a direct relationship with each other. We throw in some other variables like where we live and house size, and that's it. Okay, next I've got a histogram. All right, let's see what we got here. Who remembers what a histogram is? Well, you will now. Look what we got. So here's a histogram of our poverty rate. You know, I like the ArcGIS Pro. They're really easy to use, but you can automate these pretty easily, right? These are pretty easy. And like I said before, if someone shows something like this at a conference, like they know R. They're not putting Excel. You know, I always, whenever I make graphs in Excel, I always try to change like the graphs enough so that people don't think I did it in Excel, and they always do. They always still do. He's just an Excel guy. Okay, so I got regression models. Okay, TIM model equals linear model of poverty rate, and then it's got a little tilde. Is that such thing? I haven't heard that word since like Spanish class in 1989. Tilde, a little tilde thing. Okay, and then I print the summary of my model. So watch this. Summary of my model. Oh, what I got here. So I just ran a regression model between poverty rate and income. That green thing that you saw before. And what does it say here? Does anyone remember all this stuff here? Probability 2e minus 16. Is that high or low? Yeah, it's very significant. What is my R squared? 0.3099. That's pretty high. Now, basically, 30%, 31% of income can be described by poverty, because income in our case was the y variable, was the dependent variable. Okay, now I can do this with multiple variables as well. Remember, we started to do the multiple regression. We can do, now this is just linear, so I'm sure we can do linear multiple regression. All right, here's one last regression model using these. Yeah. Okay. P-value equals 0.199. So I was looking to see if there was a relationship between poverty rate and population density. Maybe where there's more densely populated areas, the poverty rate's higher. What do these results tell you, geostats people? Is that a yes or a no? Andy's nodding his head. Is there a relationship or a statistical relationship between poverty rate, population density. What does this tell you? Not quite significant, right? Yep, it's 0.199, almost, but not quite. Almost, but not quite. But it also tells me R squared 0.000852. Probably not. Yeah, it wants to, but we can bring in multiple variables here. And so there's tons of tools out there for this. Last thing, oh, wow, okay. Watch what I got here. All right, I've got Durham population data. Okay, year versus population. Let's look at some of this stuff. And all I'm doing is cutting and pasting here. Look what I graphed here. I got this from the state demographer. This is what population in Durham is going to look like according to one of my files. And I made it red. And so you can see I got a nice little plot right there. I can connect the lines and all this other stuff. Okay, next, I've got year versus temperature. So what I'm going to read in is this average temperature right here. So since from 1876 all the way to 2025, this is the average temperature in the world. I don't know what. And you remember, this isn't, advocating for anything or whatever here, because, this might be taken from one station at one time over a period, maybe in London or whatever, All right, so I've got some commands here, and hopefully you can kind of play with these, because I've provided all these resources. I've provided a lot of tutorials. I've got some video tutorials, so you can kind of just go through and play these, because we don't have homework this week. So you can work on GERS, or just kind of play with these. This is how I developed this, and when I did this last year, I kind of messed this thing up really bad. And so I've got a time versus temperature. This is what temperature looks like throughout the years from 1876 until now. Cool. So you can see the plot. You notice I had something different between plot and plot.ts. What's plot.ts mean? Try to make eye contact with Daniel Achinia to see if they know the difference, but what plot.ts does. Oh, it's a command in R. Command in R. I don't know. Probably when I did this back in December, it wouldn't run it, so I probably maybe because I want to do more moving averages. So let's forget about that. So the other thing we start to look at, because we have a lot of undulations, ups and downs, or whatever, and especially you got a cold spell or a warm spell that comes in the middle of January, middle, December or whatever. It's really going to skew that data for the year. So one of the things that I've created here is a moving average, and we use the term filter. I just kind of use these here, but we have moving average, and I plotted the moving average. It's a little different, right? Is it up and down? Now, what's a moving average do? I take 3 years, I take the average, that's the point. I move over a year, take those 3 years, take the average, move over a year, take those 3 years. So I'm basically doing a 3-year window. So I'm not going to have as many ups and downs, but I'll have the 3-year average. Okay, now look what I have here. I've got a 5-year moving average. It's a little different, right? You can definitely see this one that goes those 2 years that go down really low. Next, we got a 7-year moving average. Very cool, huh? Now, I think I'm going to combine all of these in one. I don't know where I have no idea what I'm doing with these commands here. I don't remember doing this, but I obviously did, you know? But I think something cool is gonna show up. Watch this. Cool. All right, and I guess I did different things for different years. All right, cool, yes. I did average temperature, I did the moving average 3 years, moving average 5 years, moving average 7 years, and somehow I changed the colors. Is that right? I guess I changed the colors for each of them with color 1, 4, 6, I don't know. I don't know, this looks pretty cool. It's busy though, it's way too busy, it's nothing that I would wanna put on, I might put like 2 on top of each other, but that's, that's about it. But what's the general trend, no matter what you have, you've got, because you can see here in 2023, the temperature is pretty low, but when you group it, when you have it as part of that average, it's not as pronounced because these other values are higher, whether they're in the 3, 5, or 7 will really kind of gobble up a wide array of numbers. Okay. Does everyone feel good about this here? This is I'll show a couple resources here where you can get stuff. We had a student here, probably 2011, 2012. He loved R. I don't love it as much because I just have to go and relearn it every time I want to use it. But I have the programming exercise, downloading data. We can install data, how to plot. I got a lot of videos here that you can go and just go and install them. So, any questions for me? Last year I screwed up this lecture because I don't know, I messed it up, but this year it looked pretty good. You can linear modeling, plotting, graphings, averages, regression, all that other good stuff that we've talked about all in one place. And you can automate these in single programs. So you can open up something.r, run it, run all those things at once. And there's ways, there'll be commands to export and all that other good stuff as well if you want. So, all right, I'll leave everyone alone for now. Those of you missing homeworks, I'm speaking to you, maybe speaking to some of you here. You got a chance to catch up on some homeworks. And probably next week it's going to be a little bit, fast class because that following Tuesday I got a 5 o'clock flight to Detroit. So I'm gonna be out real early, So if the NASA stuff isn't available, I'll probably do a little open resource and then we'll talk about open science framework because we're gonna be nice and busy with GERS and everything else. And then we got that project where you're gonna teach us how to do something. And so if someone wants to kind of take on a couple of the R commands, go ahead, do it and do a 10-minute video on how to do R commands. I would love that, so you can increase your portfolio, and the best way to learn stuff is to teach it. So I'll see you all later. And let's catch up on some things if you're not caught up yet.